Hi everyone, welcome to today's coding session. Today I'll be solving the k largest element problem using Python. I will explain the problem, its constraint, and the approach we'll be using. We will be using Python built-in heapq module. As I go, I'll explain each step in details. And let me show you here what the graph represents. So we're building k largest element, which in this case k equals 3. So we're looking for the third largest element. So this array, we're not going to sort it, but we need to find the third largest array based on this k. And here I'm putting the min heap versus max heap because we will be using both in order to solve this problem. So min heap means that the minimum value is going to be at the top. So you can see 10 at the top, and then to the left will be the next minimum value followed by the 30 to the right. And it goes like that in a staircase fashion. Same thing here for the max heap. Maximum is going to be 100, followed by 50 in this case, and then we're going to go in a staircase like fashion as well. And there will be duplicates, so we'll see. So we will be solving the following problem. As I explained, we're given an integer array num and an integer k such that k largest element in the array. So key point here is it is the k largest element in the sorted order, not the k distinct element. We're not allowed to sort the array to find a solution. So we are using min heap and max heap, but we're not sorting the array. And here, as you can see, example 2, for example, there are some repeating numbers like 3, 3, 5, 5. So that's to show you we're not doing any k distinct element, but we are trying to find the fourth element in the array. And in this case, that's going to be fourth. So if we were to sort it, we're trying to find which one is the fourth largest element in the array without having any caring about any distinct element. Same thing here. We're looking for the second largest, which is going to be fifth once we sort this, but we're not going to sort it. And same thing here. If k equaled 3, largest would have been 43. Next is 32, and then 23 is what we're looking for. Now that we understand the problem, let's think about the constraint. So the array could be very short, 1 element, or very long, 100,000 element, which is what this is explaining. And the array can contain both negative and positive number as well as 0, which is what this is explaining. The array can also contain duplicates, as we saw in example 2. So we need to correctly handle repeated values. And using a min heap allows us to maintain the k largest element without full sorting, preserving performance. Alright, so today's code will be very short since we are using a Python library. Here we go. So we're going to use heapq, which means we need to import it, the library, in order for us to use it. And we're just going to return the result of heapq and nlargest, which I'm going to explain in detail what this is doing, because this is there's a lot of iteration going on, and it's a lot of the work is being done in the back end here. So let's see if any issues here. Okay, so it's accepted, and let's see how it competes with others. So it is efficient. It takes 323 milliseconds. Could be better. And memory-wise, it could be a lot better, but nonetheless, this is an efficient, time-wise is an efficient solution, not space-wise compared to others. So here is a big picture overview of what the code is doing. It uses a min heap, as you can see here, data structure, to efficiently keep track of the k largest element. It iterates through the list num and maintains a heap of size k. At each step, it compares the current element with the smallest element in the heap. And if the current element is larger than the smallest element in the heap, it replaces the smallest element with the current element. Otherwise, it ignores the current elements. After processing all elements, the heap contains the k largest element in descending order. So let me show you this in an example. So here, first we initialize Min-Heap of size k, as you can see here. So this is the first thing we do, at least in the back end. So you're not seeing this code. Then we use the Python built-in heapq module to create a Min-Heap, which is where we had shown in the code here. So we had here, so this is what we're gonna use. And this, the way this sorts values is based on minimum heap, which is the reason I showed you at the beginning, both min-heap and max-heap. So this is doing the min-heap sorting. And then we start by taking the first k element, which in this case, we first look at the first element in the array, which is 3. Then we put it into our array since it's empty at this point. And we do the same thing with 2 since it's empty. And now we already maxed out the k value since it's only 2 value. And then we do the same thing, we compare now. We're saying is 1 greater than 2. We know that's false, so we're gonna ignore it. The list will stay the same. And then we say is 5 greater than 2, which in this case 5 is greater than 2. And then we put into the list. And the distinction that I want to point out is the reason why we have nlargest is because nlargest, once heapify gives it to you and you see the minimum value comes first followed by the greater value. Well, nlargest does the opposite. It presents, so whenever you get this result by heapq, nlargest is going to return it in this fashion. So it's going to be 3, 2. And you'll see the importance of this in the end, because once you go through this whole process of comparing 5 is 5 greater than 2, then yes it is. So then we place the array, then we put it in this order. Same thing is 6 greater than 3, which was here. We say yes, and then we place it in this order. And same thing, 4 is not greater than 5, so therefore the last one remaining is here. So now with the code that you saw, where we have here the -1, that tells you that we want to return the last element, which in this case is going to be 5, and that's the reason we get the right answer. So in regards to time complexity, as you can see, heapq.nlargest is both time efficient and space efficient. The combination of big O of nlogk time and big O of k space makes it an optimal solution for finding the k largest element in an unsorted array. By leveraging a mean heap internally, this approach ensures that the algorithm remains efficient for a large input size and value of k. And here's a graph explaining what it means to be big O of nlogk. So we know n is just going to be the size of that array, and log k, which is the portion that's doing the sorting of the algorithm, is dependent on how many values we're going to put in it. And same thing for space complexity. K is dependent on what the user provides. Do we want the second largest, the third largest? Because that'll determine the size of the array. And as you can see, it's not linear, it's just simply consistent to the size of what the user requires. So I hope this walkthrough helped you understand how to efficiently find the k largest element in an array using heap nlargest. If you found this useful, don't forget to like, subscribe, and hit the notification bell for more in-depth coding tutorial. See you next time. Happy coding.